My name is Lars Frisk and I'm responsible for this room for sample preparation. Inside you can find equipment for cutting, mounting, grinding, polishing and etching. To enter this room you need authorization from me and only me. So this is our machine for cutting of a little bit larger samples, Discotom 100. It's a brand new machine, came to us 2014. I will demonstrate manual cutting in this machine and if you later on need automatic cutting you can find that in a separate sequence. So first of all you need to select a cutting wheel. Cutting wheels for this machine you can find here. It's marked here with different hardness and a cutting wheel looks like this when it's new. When it's a little bit worn it gets smaller like that. In this particular case I'm showing a Buehler cutting wheel. This is a Struers machine but we have both Buehler and Struers cutting wheel. I will tell you later on how to select. Since we have both Struers and Buehler cutting wheels you can find a guide on the wall here to help you to select the right cutting wheel for your material. It's very easy to understand, so I think you will understand it if you look at it. Today I will demonstrate cutting with on a medium hard steel sample, looking like that. And for that I will select a wheel called B2203. On the guide here it says that it is for medium hard ferrous materials. So first of all I'm going to show you how to mount the cutting wheel in the machine. Tools for that can be found in here. And here you have a nut. And remember that this is left threaded nut, so you need to unscrew it opposite to what's normal. A flange. And here we have our cutting wheel. You remember, medium hard ferrous materials. You will also need these small paper discs, one on each side on the cutting wheel to give better friction, to avoid that the cutting wheel rotates like that on the shaft. Because if it does, it will wear down the shaft and it will start to oscillate and eventually we will have to replace the shaft. So another paper disc, the flange and the nut. Remember, left threaded, so opposite. Tool. And here is an important thing to know. This one here, if you push it, it locks the shaft so you can tighten this, but you don't need to tighten it very hard. We have several possibilities to mount the sample here. This vise can be used to hold the sample like that. Of course, it needs to fit like that into the machine. But for that particular sample, it will be much easier to use another sample holder. I will demonstrate this separately later on. And it is that sample holder. This part of the cutting table is possible to move, both for manual cutting and when you use it automatically. So I will now move it in towards the center, and because the cutting wheel will come down here. So to cut this sample now, it's not so big and I need a small piece here. I move this table all the way to the right. And I will use this sample holder. This is some kind of sample, formed sample. I would like to look at the cross section like that. So I will cut the sample here. To hold it, I will use this sample holder. It has this little foot there that goes in here. So, if you need to tighten that screw, you can use a screwdriver here coming down through that hole. But to make that possible, you will need to adjust this upwards to make it happen. Normally, it's not needed to tighten it, because when you I have to move it to that instead, because it will come too close. So remember, you have to think in advance. So, because I was about to say that you don't need to tighten that screw very hard, because when the foot comes down here, pressing on the sample, it will pull this one up, self-tightening the screw, so it will stay there this wise. So the wheel comes down here, quite close to that one. You can even see that somebody cut a little bit there. It can happen if you cut too fast. It will not be going straight down. It will be forced to one side. But I will cut a thin slice there, as I mentioned. This can be tightened harder, and when you're finished, check that it stays there properly. If you want to check meanwhile how it goes, you can pull the handle and see if it is the cut you want to do. For manual cutting, it's important that you move the sample under the cutting wheel, because during manual cutting it goes straight down like that. So I move the table. To move the table, I have to press that button. And use that joystick. So it's a two-hand operation. Okay, we should be ready to cut. Shall we try? But before cutting, we will need to see that we have the right settings for this cut, and we can do that on this panel up here. When you come to the machine, you press Escape first. Escape will take you to the main menu. Maybe you have to press it 2 or 3 times sometimes, but you come to the main menu. On the main menu, you can select the different positions on the main menu with this wheel. You can find automatic cutting methods, manual cutting method, maintenance and configuration. I will show you manual cutting today, and on a separate sequence you can see also how to make automatic cutting. So start with manual cutting. It's selected, and to make that definite, you push the button. It's 3 different selections for manual cutting here, starting on the top with the cutting wheel itself. It says 30A30, meaning that this is a Struer's cutting machine. It's also Struer's codes for cutting wheels. But if you remember it, we have a Buehler cutting wheel, B2203, for medium hard ferrous materials. And to make you understand what you're doing, I will now disappear for a moment, looking at the table back here. And I can see that Struers 30A30 is also a cutting wheel for medium hard ferrous materials, meaning that the one that we just put into the machine, or I just put into the machine, B2203, is equivalent to that one. So this setting, 30A30, is equivalent to the setting for B2203, or the wheel that I just put into the machine. So that's okay. So I would like to show you what happens if I push the button and select this cutting wheel, 30A30. A new menu comes up, and I select the first choice, Struers wheels 300 millimeter. Not that I have a Struers wheel, but I have an equivalent one. So I select that. And a new list comes up with still 30A30 selected. I can see the recommended wheel speed, which is 2,275 rotations per minute. And I can see the thickness of the cutting wheel, which is 2 millimeters. I press again. And a new display comes up, indicating this 2,775 rotations per minute, but also a bar up here. This machine has a feature where you can adjust the wheel speed, giving you the possibility to cut a little bit harder or a little bit softer material with the same cutting wheel. So if we go down in wheel speed, we can cut harder material. And if we go up in wheel speed, we can cut softer material. But I go back to 2,775, as was the original recommendation for medium hard steels. Back to the main menu for manual cutting, going down to the wheel speed. I just looked into that and it says 2,775. So I don't do anything more about that. I move down to the last possible selection, which is called ExiCut mode. So this last selection has to do with a feature called ExiCut. With no sign in front of the hand, you are just cutting manually, pulling the handle through the sample. But if you choose ExiCut, you can do that by pushing the knob there, or F1 there. It's an arrow indicating that there too. What happens if you use ExiCut is that it makes it easier to cut larger samples with a large cross section. The material that I have does not have a very large cross section, so I will not use ExiCut, but you should know it that it enhances cutting of big samples. So now I will go on to demonstrate cutting. So what remains now is only the cut itself. I will turn the machine on by pressing this button here. The wheel starts to rotate and the water cooling comes on. I take the handle, move the cutting wheel towards the sample a little bit carefully, start cutting, and I try to cut with an even motion. I have to feed slower if I have a large cross section to work towards, and I have a pretty large one now, or faster if I have a small cross section. What you can see here is the load and the temperature of the motor. And if the load, this green bar, the top one, goes too high, you're feeding too fast. At this point it's not a problem. You can probably go halfway without a problem. And now I'm through. Red button to turn it off. Like that. When you open the hood, you have to wait for a click. It's like a washing machine. And open it a little bit carefully. Otherwise, if you don't open it carefully, it will let water out on the left-hand side. So this is how the fresh cut looks. If you want to continue, take out a smaller piece to mount it and grind and polish it. You can continue and fasten it again. But I'm finished with the demonstration right now, so the only thing that remains for me is that I will demonstrate cleaning also. So I take care of the sample. For cleaning, we have a very nice feature here. Makes it very, very easy. This handle here, together with this button on the panel, gives you the possibility to clean by using this pistol here. You can clean everything inside here, rinse away all the cutting residuals. And this should be done when you're finished, every time. Not only when it looks dirty, it should be done every time. So I will move the table back. Remember, two-hand operation. So I can clean also here. Rinse down the residuals down into that hole. It goes down into the closed loop cooling tank, which is being cleaned regularly. This wool, steel wool, comes from the reinforcement in the cutting wheels. You have to pick it up before it goes, it stops at a small sieve there. Pick it up and throw it away. Remember to turn the water off. Take the cloth. I found it there. Now I prepare this. I have rinsed it with clean water before. Use this cloth with clean water and wipe off the exterior of the machine, wherever you have been with your fingers. If you have a lot of cutting residuals on the window here, you can wipe that off also. And if you've been cutting for a while, this handle might be sticky. Wipe it off also. But remember, leave open when finished. So now I'm finished with everything, cutting. I'm finished with cleaning, but I still have the sample holder here, so I have to remove that. This is my scrap. I don't need this anymore. I have taken all the samples I need, so I put it into this one here. And here goes only metal, not paper, not cutting wheels, only metal. The vise goes back into the drawer where you found it. So now you have learned how to cut samples in this machine. You have also learned how to clean the machine, which is very important. Remember that. And you should remember one more thing, and that is that you are not allowed to show your friends or anybody how to do this cutting with this machine. They can only learn by studying this film sequence or by me personally. Thank you for watching and listening.